Hello guys, welcome to this video. Now today I'll be showing you the second method of solving partial fractions, which is repeated linear factors in the denominator. Now in my previous video I showed you how to solve for distinct linear factors in the denominator. If you have not watched the video, check it out in my channel page. Now for repeated linear factors, when we have a linear factor that is a denominator, let's say x minus 1, and is repeated. When it's repeated, it means that the linear factor is raised to a given power. Let's say raised to power 2 or is raised to power 3. Is raised to power 3. So this means that it is a linear factor, and it is repeated. So now let's take this example. Let's say we have 3x plus 5 all over x plus 2. Now, if you look at the denominator, it is a linear factor because the highest power of x is 1. The highest power of the variable is 1. So this is a linear factor, and it is repeated because it has a power. So now for solving repeated linear factors, we are going to have the first partial fraction, which is a, to be the denominator is going to be x plus 2. So we are going to take the linear factor. For the first partial fraction, we are going to take the denominator of the linear factor to be just 1, while for the second one, that is plus b all over x plus 2. For the second one, take the linear factor to be raised to power 2. Now, in a scenario that we have, let's say x plus 2 raised to power 3, and this, let's say this is x. We are still going to do the same. We are going to do this till we end at the power of the linear factor. So we have a over x plus 2 all raised to power 1 plus b over x plus 2 all raised to power 2 plus c over x plus 2 all raised to power 3. So this is how we are going to solve it for repeated linear factors. Now, taking the LCM of a plus b all over x plus 1 all over x plus 2, LCM of x plus 1 x plus 2 all squared is x plus 2 all squared. So x plus 2 all squared goes into x plus 2. We are going to be left with x plus 2. So x plus 2 times a will be having a into x plus 2 plus x plus 2 all squared going to x plus 2 all squared, will be left with 1. So 1 times b will be having b. So the left hand side will have 3x plus 5 all over x plus 2 all squared. So the denominator can cancel each other in both sides. So we'll be having x plus 5 is equal to a into x plus 2 plus b. Now we'll simplify the right hand side. So we have 3x plus 5 is equal to a times x is ax plus a times 2 is 2a plus b. So we are going to be using comparison method to solve this. So comparison, I mean we'll compare the coefficient of x in both sides. Coefficient of x here is the coefficient of x here is a, and we'll compare the constants in both sides. So by comparison, we have comparing the coefficient of x in both sides, we'll have that a is equal to 3. Comparing the constants in both sides, we'll have that 2a plus b is equal to 5. So since a is equal to 3, we can put a as 3 in. This is equation 1 and this is equation 2. So we can put a as 3 in equation 2. So we have 2 into 3 plus b is equal to 5. So 2 times 3 is 6. 6 plus b is equal to 5. So b is equal to 5 minus 6. So b is equal to minus 1. So our a is 3 and our b is minus 1. Now we are going to go back into the equation we have, the partial fractions we have. We are going to input the values of a to be 3 here and b to be minus 1 here. So we have 3x plus 5 all over x plus 2 all squared is equal to a is 3, so we have 3 all over x plus 2 plus b is minus 1 bracket minus 1 all over x plus 2 all squared. So now this means that x plus 5 over x plus 2 all squared is equal to 3 over x plus 2 minus 1 over x plus 2 all squared. So this is what it means. So this is the partial fraction of this fraction.